Hello, everyone. Good morning, good evening, good afternoon, or even good night if you're actually watching this from so late. Thank you very much for tuning into this webinar. We're talking about unlocking the power of multi-tenancy and some secret strategies that make your life better. So, without any further delay, go straight to my guest today. Those are actually spending a lot of time solving challenges, and they have some wonderful solution to share with you today. So, thank you very much, Naveen, for joining us on the live webinar, and thank you very much, Rakesh,
Thank
from
you.
joining this live stream and sharing your experience. So, without any further delay, let me go straight to Rakesh. So, can you give us your cool intro, where you work, and some of your background before we start off?
Sure. Thanks, I am. So I'm Rakesh Gupta. I'm head of cloud engineering and platforms at Amlix. And I have extensive background in application development, Kubernetes in production, DevOps, SRE. And these days, I'm helping some of our large clients build, Kubernetes platforms and also helping them in their cloud migration journey and cloud adoption.
Thank you very much, Rakesh, for your intro. And now, let's go to Naveen. Naveen, can you give us a quick intro?
Hello, everyone. I'm Naveen Chakrapani. I'm part of the product management team at Rafay. At Rafay, I drive some of the initiatives, including multi-tenancy, self-service, developer environments, and so on. I've been with Rafay for over 2 years now, and prior to Rafay, I've been in product management roles at Cisco and McAfee.
So thank you very much, both of you, for your intro. So let me give you some intro to some of our audience, what we are covering today, and please correct me if I'm wrong telling this multi-tenancy story to our listeners. So I usually feel like using a single cluster with appropriate namespace for different applications if it allows efficient resource sharing, streamline management, and better scalability. So this concept is generally called as multi-tenancy. So sharing clusters save cost and simplify administration. However, sharing clusters also presents challenges around security, operational efficiency, and managing noisy neighbors. A common form of multi-tenancy is to share cluster between multiple teams within an organization, each of whom may operate one or more workloads. So these workloads may need to communicate with each other and with other workloads located on the same or different clusters. So my first question to Naveen right now is, why are customers or enterprises are looking at multi-tenant cluster? And on top of it, what are driving factor behind this, and what are your considerations?
Yeah, sure, Saim. So I'm going to use a couple of slides to talk about it. The first thing that customers kind of think about as they start their Kubernetes journey is, what's the right model for me? Should I be running dedicated clusters or should I be running multi-tenant clusters? And there's no one size fits all. And they eventually make a determination that they need a mix of both. So as they're evaluating their decision, there are three things that they often think about. Cost, as you mentioned, cost is an important consideration and is probably the most important influencer in terms of customers looking at multi-tenant clusters. There are other aspects as well, the operational overhead. You don't want to be managing hundreds of clusters for having one cluster for each application if you can consolidate and have fewer clusters, because you have to take care of upgrades, a whole bunch of other things. And the operational overhead is significant if you have a dedicated cluster model. But from a security and governance standpoint, there are additional considerations that we'll have to think about when implementing multi-tenant clusters. So it's basically customers looking at all these three factors, thinking about what they need to do. And what we've seen customers end up doing is choosing multi-tenant clusters as the default model and only allocating dedicated clusters if certain considerations are satisfied. And some of the things that have come up in customer conversations are listed on the slide. I'm not going to go through every single one of them, but there are certain things that uh, customers see in terms of the application requirements and then make a call. Should it be a dedicated cluster or should I just put that in a shared cluster. So there's a process that we've seen customers implement where they make these decisions, and it's very transparent to the end users or the application teams. And unless you do it at the beginning and you know what exactly you want to do, more often than not, you'll kind of end up running with one model, and then you'll have to fail and then course correct. So one advice that I would give to customers starting the Kubernetes journey is try to figure out what kind of applications you have in an environment, what kind of applications you're going to be taking to the containerized environment, and then figure out whether dedicated clusters or multi-tenant clusters or a mix of both is the right choice for you.
Yes, absolutely, absolutely. And I think on top of that question is like on this on the topic of this, what are you seeing the driving factor, like why people is actually is spending a lot of time and seeing one of the question. I think one of the question I spoke about, and the list is very very wonderful. The questions you're asking yourself around dedicated cluster, like the specific compliance requirement, but what is the most driving factor you have notices that people eventually move into the and specifically I'm talking about Kubernetes multi-tenancy, and what your actually considerations and what are the driving factors you have noticed?
Yeah, the driving factor, same is the cost. That's the number one item in terms of what is driving customers to look at multi-tenant clusters. The other aspect is Kubernetes upgrades need to be frequent, and it requires a lot of
Yes.
effort. So the lesser the number of clusters, as an example, the less operational overhead you'll have in just about everything, right? There are certain components that you have to deploy in each of the clusters to satisfy compliance requirements, or it could be security requirements. And then the more the number of clusters you have, the more difficult it is to maintain standardization and make sure that they're not in drift, right? So those are the two things that are primarily driving customers to look at multi-tenant clusters. So basically less operational overhead and cost, which is super important right now.
Yes, absolutely. So now I'm moving to Rakesh now and wanted to know his opinion. And I think we start up with this question. So, what are the consideration that you had to think about for implementing multi-tenancy in Kubernetes?
Yeah. So from from our perspective, from my perspective, I think the biggest driver is the cost, and cost has two aspects. One is the compute cost itself, and second is the operational cost, which comes in terms of overhead, maintenance, upgrades, LCM. The what we experienced was a cluster sprawl, and the cluster growth was exponential, and it was getting out of hand. The reason being is, every team, if you give them autonomy to create clusters, the clusters are created. Some of them are not used and are underutilized. That's the biggest driver for us to think about getting into or going towards multi-tenant Kubernetes clusters. And the key considerations I have here are, when you think about multi-tenants in Kubernetes, you have to think about different aspects. First, you can segment your multi-tenant clusters into non-prod and prod, which will actually reduce your it will create network segmentation and reduce risk, but it will sort of increase your blast radius because all prods applications are running in one cluster. So if that cluster goes down, you have to immediately do a disaster recovery, which obviously can be automated. But that is one consideration or one thing you need to think about when you deciding about your cluster, a multi-tenant cluster, the way you want to do it. Second is you can segment your clusters, like if you can have separate clusters if you want to reduce your blast radius into tier 1, tier 2, tier 3 from, segment your clusters in terms of different application criticalities. So that if, your tier 3 application cluster goes down, which is probably lower priority, your tier 1 is still up. So you sort of reducing your risk vector to some extent by using that strategy. Third is internal versus external facing. You could create your separate multi-tenant cluster for your internal, like HR, billing, your internal password resets, all those tools that you have in organizations, right? All those internal tools can be hosted in a multi-tenant internal cluster, whereas your external facing applications could go in separate multi-tenant cluster. So that's this way you're reducing your blast radius and reducing your risk vector as well. Then you can also segment your multi-tenant clusters based on your business units. You can have, every organization has different business units, verticals, and if you have multi-tenant clusters for each of those business units, that gives them autonomy to configure their clusters differently than the others, and obviously it also reduces the blast radius to some extent.
Absolutely, that's make perfect sense here for me as well. So also, I think before we let off one more question, I will go to Naveen again. So I see some of the considerations around, and the typical see the momentum is going around ephemeral environments. So people do create ephemeral environments in a multi-tenant clusters. So can you spoke about few of the things where ephemeral environments or be a part of multi-tenant cluster for some time before going into the production setup?
Yeah, sure. So usually, what we've seen customers do, same, is have a bunch of clusters that they use for testing purposes, and that's also another consideration because so you have a cluster now, and then how do you enable a self-service model for application teams to test their
Yes.
applications, right? So the way they ideally want to orchestrate is essentially allow these developers to be able to create namespaces, deploy and test their applications, but also have certain guardrails in place. Uh, Guardrails include you don't want an application team or a developer taking too much of the cluster resources. So how do you control that? And how do you control the number of namespaces, as an example, that they can potentially create? How do you ensure that after they've done uh, their testing, whatever they had to do, they do destroy the namespace, delete the namespace? So these are some of the things that our customers are thinking through as well, because it's very important to enable the self-service model. Gone are the days where you would want to have someone raise a service now ticket and then wait for days before someone on the infrastructure team or the platform team provisions necessary namespaces or resources for the application team. So more customers are gravitating towards a self-service model where they're making available a multi-tenant cluster and having developers create namespaces within the set of guardrails that they've defined, so that they can test their applications whenever they want to.
Yes, absolutely. I think that we're now moving the discussion toward this thing. Like, Naveen, what do you think? What are the typical challenges that enterprises have to solve from a security and operational efficiency standpoint of view? And what are the solutions available today?
Sure, I'll use a slide to kind of describe how our customers look at solving the guardrails problem, the governance problem. So typically, uh, what ends up happening is when customers are thinking about uh, multi-tenant clusters, the first thing is the access problem. So how do you ensure that if you're sharing a multi-tenant cluster, the relevant stakeholders have access to only their resources, their namespaces? So that's one part, right? So how do you do this? Is essentially how do you do Kubernetes RBAC at scale? And the second thing is you will have an IDP solution already in place. How do you wire that up so that when Saeem is able to reach the cluster, is able to interact with the Kube API server? So you look at Saeem's group identity and make a determination as to what resources Saeem should have access to, right? And then the other piece is essentially making sure that Saeem can access the cluster from anywhere securely. Could be working out of a cafe, and the cluster could be running in EKS or in an on-premise environment. How do you make sure that Saeem can access those clusters without having to implement expensive solutions like VPN? So in some ways, it's a trifecta uh, model where you have to bring in the Kubernetes RBAC, IDP, and the secure access together. And this is very important, and we have a capability within the platform called Zero Trust kubectl access within the Rafay platform. It's the most heavily used feature in the platform. Is so heavily used, and due to customer demand, we also open sourced it, and the solution is parallel. So we're going to have a booth at KubeCon as well if anyone wants to visit and learn more about how Palace works. So the first is a control access problem. So then the second thing is the noisy neighbor issue. So how do you make sure that the teams don't step on each other? So it's implementing isolation policies, making sure that quotas are defined appropriately, and then even in a multi-tenant cluster, you would want to measure resource utilization, because at the end of the day, you may want to implement chargebacks. You would want to make sure that the applications are right size. So you need something running in the cluster that captures the resource utilization metrics. And you also want to make sure that the resources have the right labels, so they can be appropriately identified and costs can be attached to them. And then there's always policy enforcement piece, right? There are open source tools available, Kiverno, OPA Gatekeeper, they're very effective tools to enforce policies. And from a security standpoint, from an operational efficiency standpoint, we see customers implementing it. There are certain challenges with these solutions, especially around visibility into violations. So I'll touch on it briefly. But these are the four. This is not an exhaustive list, but these are the four major things that I've seen customers think about, and they solve for it, and they try to solve for it before even kind of implementing their first production Kubernetes cluster.
Yes, absolutely. And now I move back to Rakesh again. I noticed some of the slide here mentioning the workflow. In a multi-tenant environment, what is the current workflow you actually can spoke about? Because that's very important. In a developer's environment, like we have a container, you make it where you deploy application, you want to make it an image, and then you move out to the container registry, pull it from there, make it running in the container, and deploy it the Kubernetes cluster. So in a multi-tenant setup, how the workflows look like?
Yeah, so in a multi-tenant cluster, it becomes very important that the tenant creation is automated, because then you don't have human errors, and then you have self-service. You empower your tenants to request new tenants, change tenant quota from X to Y. And then if they don't need that tenant, they can also create a request to delete the tenant. So that's what in this flow you see. This flow is what we are using currently, and this is working very well for us, where a user creates a ServiceNow request, and requests are of 3 different types and could be more in future. And then the ServiceNow invokes an Azure DevOps pipeline, which in turns, in that pipeline, a tenant is generated or updated, and we're leveraging a templating engine called a cookie cutter, which in turn uses Jinja templates. The outcome of the cookie cutter is a set of Terraform files, which will create, say, namespace, RBAC, resource quotas, policies, and also have the Helm provider to install some third-party add-ons, such as Argo CD, and a bunch of other like Nginx and all. So the YAMLs are generated, and in the fourth step, those generated files are actually checked into Git or updated in Git based on your request type. Next step is Terraform does the apply. Azure DevOps does Terraform apply. Terraform Enterprise, or just vanilla Terraform open source, will pull it from the Git, pull the file from the Git, and then create or update the tenant according to the request. And then when the Terraform applies, the Kubernetes cluster will actually pull the add-ons and other images from the private registers. Very important that the registries are locked down to only host private images, because otherwise it could pose security risk, especially because it's a multi-tenant environment. So this has worked very well for us, and we provision non-prod, prod, and even sandbox environments and multi-tenant clusters using this workflow.
Yes, absolutely. That's a super important. I think this is one of the flow that I think it's very important to understand, because a typical platform engineers and the DevOps journey is actually going through this flow, and they are actually have some separations of duties within that flow. Some part will be managed by the developers, some part managed by the platform teams, and now we see the focus towards that the platform engineering in giving developers in or a self-service capabilities. So making sure there's no more ticketing system is actually going through every time you do these steps along the journey. So I am going back to Naveen again, and I would like to see you can actually spoke about two major concepts you actually spoke about previously: a zero trust principle model in Kubernetes, and plus the separation of duties. So we start with the zero trust Kubernetes. I think essentially there are two ways to think about it. One is the RBAC, and one is the other way is around like we have a container images that are running securely and making sure that no vulnerabilities inside it. You can scan your images, and then you have a gatekeeper in your cluster that prevent you for to add a YAML file or other file that are not actually in a certain criteria. But we here speaking about a zero trust principle in Kubernetes that according to the access model, and Naveen, you can spoke about zero trust security and separation of duties.
Yeah, sure. I'll touch on that a little bit. So essentially, Saim, the way as the zero trust model works is, so you have an agent running on the cluster, and it connects back to the controller. So this means that all that you have to do is open outbound port 443. So there is no inbound ports that you need to open in your firewall, which is a big deal, right? So let's assume that the user wants to interact with the Kubernetes cluster that is running behind a firewall. It could be running anywhere, and they're using the kubectl CLI, and the same workflow holds good even if you're driving some of these things through, say, CI, CD pipeline. Same holds good if you're basically using some other tooling to interact with the API server. So one, the user kind of initiates kubectl command, and what we do is the bunch of server proxies, it first hits the proxy, and the controller is either, so if you're using Rafay solution, it hits Rafay's controller. If you're implementing Parallels, the open source version, it hits the controller that you're running in your environment. And then there is a check, is the user valid? And if the user is valid, authenticating the user and also understanding what privileges the user should have. So once that is done, and this is an important point to note, just in time, number three, just in time service account is provisioned on the cluster. So reason why this is important is, let's say Saeem is part of team one, and a week later, he is now transitioned to team two. Because the service account is provisioned just in time, it means that once Saeem moves to another team and you log in Saeem, or you try to access, uh, you probably won't have access to the cluster, because after a certain period of inactivity, we remove the service account from the cluster. So there are no dangling service accounts on the cluster that you need to care about. It's a huge thing from a compliance standpoint, right? Otherwise, it's a nightmare going and cleaning up service accounts that are not being used. Um, so once just in time service account it's created, then you just interact with QA API server just like you would do. And then, as I mentioned, we also auto deprovision service account, which is a big deal. And then all these activities are audited. So if you want to go back in time and look at what commands an user ran, it's very easy to do that.
Yes, absolutely. And I think if you look at the if you live in the Kubernetes world specifically, you see some of the challenges around like implementing a role-based access control, and this has a hierarchy of learning. You have a role, and then you bind that role to an entity or user or the system as a role binding object. So you need to circulate three YAML files for, because in Kubernetes we don't have any user, Let's say you can ask kubectl get user, where a list of the user you actually see who are the user in Kubernetes cluster. That is not available. So Kubernetes has implemented role-based access control, meaning, let's say, do you allow to see pods, replica set, deployment, ingress, or all object? Are you allowed to do it? If you are allowed to do it, then you have a specific role to that. And if you are bind to that role, you can actually see all the services, pods, deployment, ingress set in your cluster. If you don't have a role, then we typically mean you have another role binding that doesn't allow you to see those secret information in Kubernetes. Implementing those can be a cumbersome, and it's not your job. Your job is to innovate with the business and you make faster and have a faster delivery of services, but you still want a restricted restriction in your cluster. So that's where I think uh, zero trust access model really shines here, because the just-in-time service account token, and we typically have an open source project called Parallels, and during KubeCon we have a CNCF providing us a project pavilion, and one of the project pavilion is F35, where you can meet the team, and hopefully Naveen is there to spoke about these things as well. So now I before I going to the can you before I going to the Rakesh, just a quick tip around a separation of duties. Naveen, can you spoke about few nits details around how to separate duties within the cluster?
Yeah, so usually what ends up happening, and another thing that I forgot to mention, Saeed. So one thing that customers deeply care about is the source of truth, and you would want the source of truth to be at one place, and it is widely standardized, and the source of truth is the identity provider. So ability to use what information is available in the identity provider and use that to drive the privileges that the user has when accessing the cluster is very important. And typically, to your question, Saim, so what we've seen customers do is, of course, there's a hierarchy of roles. And so the infra team, the platform team has cluster-wide privileges. And then the developers, the application teams, are basically restricted to certain namespaces. And then the few models that we see customers adopting. One is essentially users have maybe read-write access to test clusters, but only read access to production clusters, or developers have read-write access to test clusters, but no access to the production clusters. And there is a break glass procedure in place where only if developers need access for whatever reason, the application is there's some issues with the application, the production environment, logs need to be collected. So only during that time, for a specific period of time, developers are provided access. So break glass is also something that we commonly see. But the typical model is the platform team and the team that takes care of cluster upgrades, etc., has cluster-wide access. But and then the other teams, um, development teams have access to only namespaces, and all of these are mapped to roles that we have within the platform. So Rafay platform has inbuilt roles that kind of map to each of these personas.
Yes, absolutely, absolutely. So now we're actually moving a next turn to this discussion here, and that's very important. And I think Rakesh can actually walk us through. So Rakesh, I'm going towards you. So what are the major challenges you have seen organization face when implementing multi-tenancy in Kubernetes?
Yes, absolutely. See, multi-tenancy, I believe, is a necessary evil as if you want to curtail your cost and operational burden. It is something that most organizations will need, right? And obviously, it comes with some complexity because Kubernetes inherently doesn't have these capabilities out of the box. You have to configure different tools and make things happen. And one of the challenge that even Naveen touched base upon earlier was tenant isolation and fairness. Isolation is very important if you're hosting multiple tenants in the same cluster. You have noisy neighbors. One application could consume all the resources and depriving other applications and making them slow in response time, costing them response time. east-west, north-south traffic, and how do you prevent all that, and at the same time allowing the services running inside the cluster to reach at least the common services like kubedns, kubeproxy and others. So all those should be allowed, while uh, communication from one namespace to the other may be blocked depending on the business use case. So isolation and fairness is a big challenge that everyone who's getting into multi-tenancy will face. Some recommendations that I propose is, obviously we can have namespace-based tenants. We can have cluster admin that creates namespace, with annotations and labels. Annotations and labels are really important. We'll see this also later when we're trying to charge back or calculate cost. That is also done using labels. And some security enforcement is done using annotations, like if you're using twistlock and all. Then you have to create namespace admins, allocate resource quotas to the namespaces, so the fairness is enforced. Tenants will not be go out of their bounds and consume as much resources. They will be bound by the resource quotas. Then the second user is the namespace admin that will be able to manage their namespaces, right, and also set limit ranges that are still bound by the resource quotas. Then the users are actually the non-policy, are the users which will be deploying manifest, right, deploying their workloads in their designated namespaces, and they will be bound by all the above. So this is some way we were able to isolate and provide fairness to the tenants inside the cluster.
And I think like you absolutely. And I think before just a one question here from I think we spoke about do things label annotations are very important for the chargeback for the cost associated thing. So one of the questions we see often people keep describing. So multi-tenancy is your model when you have a cost management because dedicated cluster will actually end up so much cost associated to it. But there are some times and there are some anti-patterns where multi-tenancy in itself paying off the cost. And you actually have
Absolutely. Yeah, so instead of having 5 nodes per cluster, you can have 5 applications sharing those, 5 nodes, and then that drives efficiency and cluster density, and it really helps, lower your cost. And with tight budgets these days, multi-tenancy is something, is taking ground.
yes, absolutely, absolutely. Go ahead, Rakesh. I will ask more questions as we go.
Sure. So the next one is the cluster scoped objects. So in multi-tenancy, we face the challenge that people wanted to create their storage classes, CRDs, which are custom resource definitions, and other non-namespace scoped objects. And the challenge is that you can't grant the namespace admins or the users the access to create CRDs because they apply to the whole cluster and will affect all the tenants. So it also poses security risk because then you are getting out of your namespace bounds and getting access to the namespace. The consideration here is that the cluster platform team or the platform operations team, will get a request to install a certain CRD or create a storage class to say provide persistence in their clusters. The Helm is really useful. Terraform provider for Helm allows you to roll out these CRDs very efficiently, effectively. Put all your Helm charts and everything in Git, make it golden source, and leverage infrastructure as code and automation with pipeline as code wherever possible. So cluster CRDs and all these add-ons third party that require cluster access or getting installed using some elevated privileges and not being done by some individual because that will leave some remnants and security holes. So
Yes,
next
absolutely.
is the next challenge, Naveen. Yeah. So this is another thing that we faced actually, and I believe everyone will who gets into multi-tenancy is from time to time Kubernetes, as the versions change or Kubernetes releases new versions, they tend to consolidate some of those APIs or deprecate. So now if your workload is using, say, HPA using V2 Beta 1 API resource, and if you're trying to upgrade from 1.21 to 1.22, your application will not scale because HPA will not work in 1.22. You'll have to update your API version. Similarly, part security policy was deprecated in V1.25, and your application, will obviously be affected if you upgrade it. So how do you stay on top of this, right? How do you make sure that your cluster upgrade will not break your application and cause outages? So what we have leveraged is an open source tool called Cube No Trouble. And I provided some a screenshot of the execution at the bottom. And before upgrading your cluster, just to run Cube No Trouble on that cluster, it will tell you which API resources are deprecating in which version, right? And this you can automate using this information. You can actually alert your tenants and create some tickets so it gets tracked, and make sure that the tenants are responsible for remediation and changing these API resources. Otherwise, with cluster upgrade, their application could break. Um, right. So it's important, very integral part of cluster upgrades and updates. Without this, your upgrade schedule will slip, and you will not be able to do regular Kubernetes upgrades. And generally, it's just recommended that you do not stay behind two versions on Kubernetes. You try to stay, updated and upgraded to the latest or one version behind.
Yes, absolutely. And Rakesh, on the same lines, lad, that the deprecation of API is not just gonna die anytime soon. In 29, I have 1.29, there are more and more deprecations coming up, and they're already been seeing some of the discussion happening. And I think you recommend the tool called Cube No Trouble. And I think also people would like to listen if somebody watching us from open source space. There are tools like Kyverno or Open Policy Agent. Those has some kind of policies that you can add, and those policies watch for the deprecated API, and then you can actually consume the Kyverno policy report or something called reporters or some kind of mechanism that I can tell you upfront there are some deprecated APIs. Once first you fix it up, then I can help you update the or actually upload the workload that you wanted to solve in. So one of the tools you actually mentioned, and also like on the question of this, like deprecation API is like I think not going to die anytime sooner, and we have some kind of checks in place. What are the custom admission controller? How those custom admission controller can help us out here?
So there are, as you mentioned, there are multiple numerous ways to solve this problem. This is something that we employed and has worked in our workflow that I defined earlier, because I wanted to, keep this very automated, using tickets and provide remediation steps, documentation, and then also track. Custom admission controllers can prevent a workload to be deployed if there is a deprecated API in their workload. So it could help you in that way. So there are multiple ways of solving this, and there are numerous tools. And obviously, everybody's use case is different. This has really helped us. Cube No Trouble has really helped us in solving this, deprecation issue that were preventing us from upgrading our clusters. So it looks like we've lost Sam. Naveen, are you?
Yeah. So do you want to continue talking about the other
Yes.
challenges, Rakesh,
Yeah, he
as
might
we
be
wait for
having
him to join
some,
back? Hmm.
network issues. The next challenge I would like to talk about is the upgrade, and we have actually talked about in depth already because upgrade schedule is very important. You want to stay to the You don't want to lag behind two versions of Kubernetes, because the APIs get deprecated and new features are added or removed, old features are consolidated. So it's highly recommended that you don't lag behind, because then the upgrades themselves become an issue, because you have to upgrade from say 1.23 to 2.4 first, then 2.5 to say it's just not elegant sometimes, and cause issues. So the challenge that we had is that in a multi-tenant system, how do you come up with a upgrade schedule, because the tenants releases are different. So what we have established is a monthly upgrade, no, the window, which has been discussed and agreed upon by all the tenants, and by the segment leaders, right, vertical leaders. And we have come up with a window where the platform team will upgrade the clusters. Obviously, before upgrade can happen, we would have worked with them to get the API deprecated APIs resolved. Otherwise, upgrade will obviously not be, it could they could affect the application. We send reminders about the upcoming upgrade, so people know that, hey, we gotta remove these APIs and resolve these issues ahead of time, right? So it doesn't happen during that upgrade. Um, so we suggest that, hey, try the upgrade first in the sandbox, and then in non-prod, just to reduce your blast or risk vector. And then only when your non-prod cluster and applications are working, what we do is we promote it to say a DR, because not much is running there. So that is very production-like. So we run it on DR, upgrade the DR cluster, and then in our prod clusters, because this gives us some level of confidence in terms of upgrades.
Yes.
Yeah, I'm sure there are more challenges, Rakesh, but there are a couple of things that I wanted to ask, because I think our customers will benefit immensely knowing how you kind of approach things. So the first question that I had was, so how did you go about like establishing? I know that you have like a platform team, a centralized practice. How did you go about doing that, and was it a top-down decision? How did that come about? And the second thing is, how are you then working with the application teams to onboard? Because a lot of our customers are interested in understanding that, because they're in various stages of their Kubernetes journey. And more often than not, you have this paradigm where people are spinning up their own clusters and they decide, hey, this is it's too much. Let's establish a central platform team, establish a set of guidelines and practices, and then have that team support all of the other teams that are running applications in Kubernetes environments. Can you talk a little bit about the journey? Because that's something that I've heard customers kind of complain about, ask about, and it'd be great for them to understand and learn from what you did.
Sure. So in especially in medium and large organizations, you have lots of applications, north of 100, 200 applications. What we did was we created a list of brownfield and greenfield applications. Brownfield applications from multi-tenancy perspective to us meant the applications that are already running in dedicated Kubernetes clusters. Okay, they're already in Kubernetes. How do we consolidate them in a multi-tenant cluster? So that is our first list of applications that we pull from our APM. And then the other list is the other applications that were running on, say, VMs, or say Azure container instances, or AWS Fargate, containerized or sometimes not containerized. List of those applications, we call them greenfield from cluster perspective, that they're not in Kubernetes yet. So then we bucket those in terms of their size. We get their size from their application, from the cloud providers, the current spend and all, and then based on the most critical applications, and then going down towards the lower critical, or applications that are not consuming or not having many users. So we establish, we conduct a discovery and assessment session with their application team, just to understand whether the move to a shared multi-tenant platform is viable for them. And in this step, in discovery and assessment step, also we explain the benefits of shared platform, the governance, risk compliance that comes with it, the integration of tools like security, automation, GitOps, all that we have baked into the platform. So we provide all these benefits to them, and most of the times they agree to working with us um, in moving their applications to the clusters. And once we have an application that is that is willing to participate and move into a shared multi-tenant cluster, we provide them guidance on the best practices, because sometimes they don't have any GitOps workflow. They are still doing Jenkins based deploys. So we would try to improve their CI/CD along the way, so they become more robust and more automated. So for actually helping the teams, we have created a platform and operations team, which in terms has three micro teams, right? Inside that team, we have three micro teams. One is the delivery team. Delivery team is the one who works with the applications team, understands the architecture, the current setup, current landscape, and tries to come up with a translated form in a shared tenant. How your multiple workloads will then reside in this namespace, who will be the users, who will be the SRE users. So all that information is gathered and provided to them. This team also helps them create the pipelines, and helm charts if necessary, because not many teams are well versed with these technical skills. Next is the platform team itself. Platform team's goal is to actually continuously evolve the offerings, right? Maybe yesterday you didn't have integration with Prisma Cloud Twistlock, but tomorrow, platform team will work with the vendor, get the integrations done, and then add provided as an offering. So that is what platform team does. They also write the automation to actually create tenants. When a new request comes in, the platform team's automation actually creates those tenants in the shared cluster. And then the operations team, right? From every now and then, there will be some issue, deprecated API, with their application. So that's where the platform operations team gets engaged and works with the application ad hoc basis.
Absolutely. Thank you very much, Rakesh, for the wonderful journey of laying down the structure of the team. Just one question on that side note is, what is the shared responsibility model in a multi-tenant setup? Because they're not just one team taking care of everything. There are multiple teams working asynchronously sometime, and sometime they broke some stuff up. So what do you think? What could be the shared responsibility model?
Yes, very, very nice question. And shared responsibility falls under, say, fairness and isolation we discussed earlier. Um, just because you have, say, X amount of quota doesn't mean that you should be setting your, limits so high that you can consume more resources. The responsibility also falls on the tenants, that they should use, say, vertical pod autoscaler to VPAs to identify their actual resource quota utilization. And through different analysis also, the resource limits need to be defined appropriately. Otherwise, clusters will scale and cost everyone, whoever is tenant, right? As the cluster scales unnecessarily, the cost gets reallocated to the or charged back to the tenants, and it inflates the cost unnecessarily. That is something. And other is trying not to run everything with root users in privileged mode. That is really important in the multi-tenant environment. Security, making sure that you are not trying to push everything as root. Obviously, as a platform, we have implemented some policies, OPA gatekeeper policies, that will restrict pods that are containers that run as root, and preempt them before they spin up or initiate in cluster. So there is some responsibility from the platform, and some responsibility lies with the tenants themselves.
Yes. Yes, absolutely, absolutely. And Naveen, do you want to share anything on this front?
Yeah, sure. It's so as I mentioned, one of the key things is basically laying out the entire process in terms of who does what, and also making sure that the appropriate guardrails are in place, right? As Rakesh mentioned, it's impossible to have tenant isolation. It's important to enforce quotas, and it's also important to track utilization, because then you can have and also make those metrics available to the application teams. Because from a self-service model, when we talk about a self-service model, it's not just self-service to provision the necessary infrastructure to run the applications. It's also about the other things, getting to know the violations, as an example, policy violations against your resources, so that the application teams can just self-correct without having to rely on someone reaching out to them. The ability for the application teams to understand the cost structure, the utilization metrics, so they can go and do application right sizing without someone having to provide them data to do that. So a lot of them, if they can be uh, done synchronously, and uh, the application teams have access to the necessary data to make decisions, so that will make sure that the optimization exercises are carried out in a timely manner, and also it reduces the burden on the platform teams. Otherwise, it places an enormous burden on platform teams, and they won't be able to scale easily.
Yeah, I just want to add something else here, that the tenants don't try to, generally, I mean, internal tenants especially, don't try to sabotage knowingly, or
Yep.
consume too many resources knowingly. They just don't know sometimes how to configure or fine tune their application. So as part of our platform development, we have created extensive documentation in SharePoint, Confluence. What we have done, and we use Confluence. We've created extensive documentation on how to use a vertical pod autoscaler to find the actual resource utilization for your pods, and then use those values as your requests and limits to only allocate the resources that your application actually needs. Otherwise, you could be over or under allocating. So these are something that we try to help our tenants to stay on top of their responsibilities, because they may not have information on how to do those right way. Hey Sam, you're mute.
So thank you for letting me know. So we before we leave off, just a rapid fire question, a quick question for both of you from the open source world. So we see in the open source world there are tools like virtual clusters. Instead of having a full dedicated, we actually have a create another, like we have a two-way of tenant isolation we spoke about today's webinar is around namespace isolation, and we have a V cluster, like you can create another fully conformant clusters where all the updates in here. So the question becomes this one: have you seen organization switching to virtual clusters?
Okay, can I take that first, Rakesh, if you don't mind?
Please, please.
Yeah, same. The answer is yes, especially when the application teams are uh, testing out stuff which requires CRD access. So vClusters is probably the easiest way to go about doing things. But all the challenges that Rakesh kind of spoke about, all the challenges that I spoke about, are still valid, because the virtual cluster is running within a specific namespace context. So if you still want tenant isolation, you need to do namespace isolation. Namespace isolation will do the vCluster isolation under the hood. If you want to apply policies, if you want to track usage, etc. So all of the guardrails that we spoke about are are relevant in the vCluster world as well. So it's just that instead of namespaces, you're looking at a vCluster which is still operating within a namespace scope. So none of the things that we spoke about really change. It's just yet another model for customers to provide an environment for their application teams, especially in cases where they need cluster-wide access to try out things.
Yeah, and the V clusters add a layer of abstraction that could actually cause some slowness to your applications, because it's nested clusterization, for lack of better word, right? Like nested virtualization is a term. I don't know if nested clusterization is a term, but when you try to create a VM from a VM, the child VM will obviously have slow response than your parent VM. So you got to consider those and make sure that your KPIs and SLAs are being met if you want to at all use virtual clusters.
Yes, and one more rapid fire. Have you seen people shift transition from dedicated to multi-tenant cluster, but it hasn't dropped any spike in their cost management?
That usually doesn't happen, Saeem, because if that has happened, it means that in the choice to move to a multi-tenant cluster model was the wrong one in the first
Yes.
place. So typically, what happens is because there's this burden of moving stuff to a multi-tenant environment. So unless uh, you can for sure prove that from a math standpoint, the multi-tenant cluster model does work. And no one's going to start moving things willy-nilly to a multi-tenant cluster model. And even customers also approach it in phases, right? So you'll probably set up one multi-tenant cluster, you will move a few applications, then you will have to demonstrate that the additional burden of managing multi-tenant clusters is offset by the savings and costs. Uh, so maybe in a partial manner, customers try it out and it doesn't work out. But I've not seen customers go down that path and basically realize later that, hey, this is not working out for me.
Oh, looks like you're awaiting my response. Um,
Yeah, Rakesh. So basically, Saim's question was, is there a case where you probably thought about a multi-tenant model, then basically it didn't make sense, and dedicated cluster, the original model is probably the right choice. So he's asking whether there were any scenarios where you kind of ran into this.
I think when you are creating a solution, there will always be some challenges. As long as you are able to navigate through those challenges, it makes sense. But if there's a challenge that you cannot resolve, only then in those situations, for example, suppose your application requires privilege to be run in privilege mode, right, with root and access to the kernel, modified kernel parameters.
Hmm.
Like if it could be requirement by the application, right? Then in those clusters dedicated, you might try and fail and then move back to a dedicated cluster. But even
Hmm.
in those cases, there are some solutions like creating dedicated node pools and using taints and tolerations to restrict those workloads only to certain nodes, right? But
Hmm.
that may not be feasible, or that may not be a valid solution for your use case. Sometimes, with HIPAA, with the compliance, government and legal compliance requirements, you may not know that you cannot put in a multi-tenant cluster, but later you come to realize that, oh, because of these requirements, I can't put it in a multi-tenant cluster because there is a legal requirement, and then roll it back to a dedicated cluster. So there are some situations which could arise, but it should be taken on a case by case basis.
Hmm.
Yes, absolutely. So before I wrap up, thank you very much, both of you. And can you go to the next few slide, Naveen, so we can people tell people about there's a one dedicated conference happening in the multi-tenancy con era, so people can join in. So if people are listening to us and we spoke about zero trust security model access management, there's an open source school called Parallels, and there's a dedicated booth in KubeCon. So please join. There's a team available, experts and maintainers who can spoke about the real world use cases of implementation. And there's a dedicated multi-tenancy con happening there. And Naveen has a talk with Thomas from Falco community around enhancing the security posture for the multi-tenant cluster. So if you want to join the conference, make sure to tune into that podcast as well. So before I leave you off, few sentences, next few waves about multi-tenancies. A very few liner in the few sentences.
Yeah, we'll continue to see innovation, Saeem. I think the adoption of multi-tenant environments will continue to grow because there's pressure on organizations to save costs. So we'll see novel solutions. We'll have to. I don't know what shape and form those are going to be in, but this is going to be a space where there's going to be significant activity going forward.
Yes,
And Rakesh,
absolutely.
same question.
Yeah, so multi-tenancy is here to stay. It depends on the use case. It varies from use case to use case, but there will always be some use cases in every organization that are a perfect case for multi-tenancy. Applications need to be evaluated and assessed, and then proper decisioning needs to be done at the right stages. So you don't have to go back to say dedicated cluster when you initially try to go in a multi-tenant cluster. So those evaluation assessments need to happen, and once that information is present, the multi-tenancy with the automation, with regular upgrades and updates to the clusters, and with proper integrations, is actually going to help a lot of the tenants, because they don't have expertise to say integrate with all these tools and technologies and implement those in the cluster. Whereas one platform team can be built, who they're strong in Kubernetes, they can actually do a lot of research and provide elegant solutions to solving these the goals of the organization, right, in terms of compliance, risk, and governance.
I think we lost Saim again.
Oh, sorry. I think, oh, sorry, I lost again. So, no worries. Thank you very much, both of you. I really enjoyed the conversation. And I will share the link with the audience for the slide deck if they want to go through their slide deck is well available. And also, will share the link, some of the blog posts, some of the conference link, and some of the things we spoke about from the organization enterprise standpoint of view. So I learned a lot, what you actually learned, and how you feel about multi-tenancy. Please post this, those your question in the chat below. So we will be looking forward to the conversation in the YouTube chat as well. So once again, thank you very much, Rakesh. Wonderful learning session for me, and I hope for audience as well. And thank you very much, Naveen, for your dedicated session around and telling us the consideration and how the enterprises are looking for tackling the challenges associated to multi-tenancy. We'll meet again soon with another webinar. And thank you very much for joining me today. Have a
Yeah,
wonderful day,
thank
everyone.
you.
Stay safe, stay
Thank you all.
healthy.
Thank
Good
you.
day. Bye.
Thank you.